Look on the lab one, and what correction did I make in the lab one?
Let's see where you said spring instead of extensions.
Right. So use a spring. Um, this should be changed. This doesn't make any sense. So this should be, let's say, use a spring. Use a spring with nothing attached as a
Yeah.
zero mark, right? So with nothing attached, you will have a zero mark. Use extension with nothing, or is a length. Use the length of the spring with nothing attached as a zero mark. That is the updated method. And what other correction did I make?
Uh, the apparat for the first, the number one in the method,
Yeah.
the apparatus was set up
All right.
as
So yeah, so you should write in past tense, and you know that already, right?
yes, sir.
Yeah. So I see that for Mr. Blake, the apparatus was as shown in a diagram above. Um, the extension with nothing attached was used as a zero mark. All right. So the length of a spring, and what is this now? Yeah, length of the spring. Um, the length of the spring with nothing attached was used as a zero mark. All right, so that particular point, the length of the spring with nothing attached, that's a zero mark. So this makes more sense. And which other correction did I make?
For number four,
Yeah.
um, it's not 10 grams, it's 100 grams.
All right, so 100 grams. Right, 100 grams, and what else?
Just that alone.
Just that alone. So add 100 grams concentrated to mass, balance, and record the corresponding weight. So take a picture of this and send it into the group, please. All right, just snap a picture of this. This is the updated method. All right, finish.
Yes, sir.
All right. I'm just hearing the click. Do it again.
Yeah, I already do already, sir.
Okay. The click was delayed then. All right, so the second part now that I want you to focus on. All right, so as I said, you don't have to do all the questions here, right? You don't have to do all the questions here. What you want to do is to include as much as possible as you can, right? Right. These are just use the guide. So of course, define Hooke's law. Is there extent limit for expansion of a spring? Explain how they limit. All right, so we can scrap. You should use a graph. So of course you have to have a graph. You cannot get 10 out of 10 without a graph. You looking at the mark scheme here. Looking at the mark scheme here. State the relationship between force and added extension. You cannot state the relationship of something without a graph. Right? That's my rule. So you're not able to state the relationship between force and added extension without a graph. So you plot a graph of what should be a graph, what should be on the y-axis for your graph.
Uh,
Let me get my pen. What do you think should be on the y? Let's go back to the method. Look at this. What should be on the y-axis?
extension.
The extension should be on the y-axis. Remember we went through this already. Right, this is the last. I see somebody else. So I'm not sure
Yeah,
who's
so you
that.
need to ask the guy in the class. So,
Who's that?
person
Oh.
that
Mhm. Okay. All right. All right, let's go again. So, yeah. Now, the graph, you should have your extension over here. Extension. Of course, you write out the word extension and you write out the word force down here. All right, your graph should look something like this. I'm hearing some feedback from, is this Mr. Blake?
Yes, sir.
Yeah, I'm hearing some feedback from Mike, all right?
Oh, yeah, all right.
All right. Yeah. What did I do? Okay. So ensure that you have a graph. You're not able to get the full 4 marks here. You should go through and ensure that you get your full marks for your part. So this is a very easy section, right? All steps should be in correct sequence. Table. I did not put certain marks or certain things, right? But ensure you have a table and you state the relationship between force and added extension. You're not able to do this without your without a graph. You're not able to state the relationship because then you would be able to say, okay, the force is directly proportional or or inversely proportional. Anyone that you choose, right? Right. So is it directly or inversely proportional? Are they both directly or inversely proportional?
Inverse.
No, right? If you draw a graph, you will see that you get a straight line. All right, you get a
Sir,
straight line.
what this a graph? How we draw the graph upon graph paper?
You graph on graph paper, exactly. So you draw the
And
force here and your extension up here. All right,
force. So what is again? Hooke's law.
so all right,
Force extension. All right, sir.
all right, very simple stuff.
I write out you do something them. Write out different um length, a different extension and enforce something on the bottom and it on the side.
Exactly. All right. So is this clear? Mr. Hamilton is joining, but yes, moving on the slow. Let me wait a second to see if he joins. All right. Welcome, Mr. Hamilton.
Side, Mr. Side, come on.
All right. So ensure, Mr. Hamilton, just go back through your method. Ensure that it is in past tense, and also that you to make these changes, right? So I made a change here, 100 grams, right? Probably if you go back to your Mr. Hamilton, are you hearing me?
So
Mr. Hamilton, are you hearing me? Yes, no. All right, moving on. You got a question, Mr. Blake? No question?
yes, sir. I mean, the number four yes, you make change to sir. When you make a change to it.
Yeah, just no. All right. Yeah, because we were
Yeah.
reading it back over and we realized that it doesn't make any sense. So remember, we added 100 grams consecutively to the spring, and then we recorded the corresponding weight and extension.
Yeah.
All right.
So when you change that, you will change it down.
It was a 10. No, it's at 100. All right. So just remember to
Yeah.
send the picture in the group. Remember to send the picture of this in the group. All right.
Which one?
Give me a second.
So I forgot after this. So edit this.
Yeah, it's very simple. Just edit the number 4 and number 2. All right. Let me try to do this.
Yeah, Use the extension with nothing your mark. Use
Yeah,
the
so
length
it
of
should be use the length of the spring with nothing attached as the zero mark. All right, we just made a few changes there. But that's the main issue. That's the main issue that I saw.
so basically even though we you change the method them, it not gonna have no that have an impact on the results that we get before, so I have to
No,
change
no,
it.
no, man. It's just that it doesn't make any sense.
Oh,
All right, so if we change the method, it doesn't impact. We did the same thing. All right. Yeah, so remember your graph. Remember your limitations, sources of errors, right? Precaution, conclusion. All right, when doing your lab, these are very important. Your moderator is going to be looking out for these.
So
All right, go again.
have those in the lab, sir?
Right, so limitations. Remember we spoke about some limitations, things that could cause things that can affect our results that we're not able to to change. Things in our results that we're not able to change. So for example, you could say for your limitation, what are some things that you're not able to change for your limitation that could affect your results if you go back to the lab?
amount of weight to it or withstand.
Hmm?
The amount of newtons them what the spring can withstand until it become deformed beyond the point of repair or whatever.
No, that wouldn't necessarily be a limitation there. Right? What could affect your results? What could cause an error that you're not able to change?
Wind pressure, sir.
Go again?
Wind pressure.
All right, you said the wind pressure. You're talking about the wind, right? The wind could cause the spring to shake, right?
Mm-hmm.
Yeah.
Oh,
And so
not
the wind could cause the spring to shake, right? And then that could cause your system not to be balanced, right?
yeah.
Giving you an incorrect reading.
And on an unbalanced surface too.
And it was also, so write these down now, no, please. Write these down. The table was not balanced. The table had a lot of stuff on it, right? It was a smooth surface, so therefore the thing was shaking as well, giving you an incorrect reading.
Yes.
You write that down?
Yes, sir.
And what else? What other limitation? I'm thinking about one more. The fact that there was no line. No line was present on the spring for correct. No line was present on the spring for correct reading. Right? There was no, like you would have, for example, you have a spring here. There was no line from here, right, that we could use to measure use the ruler and measure it exactly to match it up to the length of the spring. So there was no line or no, you would say, let me see, how else could you say that? There was no mark there was no mark on the spring to help us to be able to measure the thing. So you only need one limitation. So you can choose out of those three limitations. What is the source of error?
Yeah, I can't find the book, you know. Yo, I'm telling you, yeah.
Yes. Suppose I don't have no source of error. Still have a put it there?
You have source of error. You are an experimenter, right? You're going to always have source of error. You're going to have some way, and if you can't, remember Google. I'm not supposed to tell you this right now, but remember you can use Google as well. You can use Google, and if you're not able to come up with one, you can go on Google and Google help you to come up with them. But by right, you're supposed to come up with a source of error from the lab, right? So think about source of error are things that errors are, for example, mistakes that we could have made in the lab. So what are some mistakes that we could make?
Because it's like the start over, sir.
Go again?
Then try
Start over. Like if we start over back to lab.
Start over the lab.
try extension before the spring gets stable. So while
All
it's
right,
still in
that's a
motion,
good one. So before the spring was stable, we tried to get the extension. So that's a good one. So the spring was never ever stable, but we tried to get an extension. That's a good one. So write that one down. Another one could be parallax error. Always go back to parallax error. If you can't come up with one, go to parallax error. Parallax error meaning that you have, let me see here. You have the ruler here.
Sir, which
Go
one
ahead.
I do again?
This is Hooke's law.
No, as in the question.
Source of error. Source of error. So say this is 10 and this is 20, right? You're supposed to read the thing at eye level. This is called eye level, in line with your eye. But say you read from down here. That is what we call parallax error. So you will not get the exact reading. You will be reading something like 10.1, 10.2. But the thing is, the trick is that you can never read at eye level. You can try, but you are never able, you're not ever at eye level. So that's a source of error. Parallax error when reading the ruler or when measuring the length of extension, anyone that you would like to choose. Is that clear?
Yes, sir.
You write it down?
Yes, sir.
No. What is a precaution now? What would be a precaution? What precaution did you take when doing the experiment? What step did you take to ensure that the experiment was safe and you got good measurements for your lab?
Make sure say the spring will align with the ruler at the 0 centimeter mark.
Exactly. That's a good point. So you ensure that the 0 mark on the ruler was in line with the top of the spring.
Yes, sir.
That's a good one, right? Which other precaution could you take?
Make it's something me and my wall up.
The
No.
clamp stand?
Yes, a clamp stand, right?
Yeah.
Yeah. So you have to adjust it, you have to tune up it properly. So because there's like one specific way how you have to set up it. So we ensure
Right.
that this.
Yeah, I was the one that did it, right?
Yeah.
So you didn't get to experience it, but that's true. You must ensure that the clamp stand is tightened at all times. Clamp stand is tightened. Clamp stand is tightened. So write these down. Right? It's tightened. All right. And for your conclusion now, you should match up your conclusion to your aim at all times.
Okay.
All right, match up your conclusion to your aim. So your aim is to investigate the elastic properties of a spring and the extent to which it obeys Hooke's law So you will say that you would say something along the lines of the spring obeys Hooke's law, and essentially the extension of a spring is directly proportional to the force, or the force is directly proportional to the extension of the spring. That is your conclusion. Every lab must have a conclusion. Every single lab that you do, it must have a conclusion.
Where's the repeat?
Every lab must have a conclusion.
That's something.
Right. I was saying that the conclusion should match up to your aim. You should answer your aim in your conclusion.
All right.
Match up your aim with your conclusion at all times. All right. So is that clear for everyone so far?
Yes, sir.
Right. And if you make a mistake in a lab, right, I won't punish you. You can use a paper, right, and cut it out and do your thing. But make sure that it's neat and it's not sloppy. Right, but you can use a paper and paste over an area or a line of word. Right, these are some things just to make sure it's neat. All right. Yeah. So if you do all of these things that we said, yeah, I have to give you 10 marks. You have to ensure that your table is neat. So your table must have a title, table showing results. It's an example of a title that you can use for other labs. I did the first one for you. Ensure that you have your units as well. Meters should be here, right? If you do these things, I have to give you a 10 out of 10. I cannot give you less than that. All right, so for the next one,
Yes.
density. This was very easy. I didn't see any trouble. Mr.
You know, so many.
Hmm?
You know, so many never get see that they love there.
Oh, you weren't in that class for that one?
So, but we do them, you know.
Yeah, I see. That's that you're doing it. All right, so ensure that your table has a title. That is very important. Ensure that you have your proper headings, units, and so forth. That's where your mark is, and ensure that you answer as much questions in your thing as possible. I see a question. Your question. Yeah, we did it. Mr. Hamilton. Right, we did it. We will send it in the group. Alger, did you get to send it as it, or are you using a phone for Zoom call?
Did that, sir?
You're sending the thing for the picture for lab one?
I'll try, sir.
Yeah. Or you're using your phone? Are you using your phone for the call now?
Yes, sir.
All right, when you're finished, all right, you can do that. All right, so for the second one, this is also very easy. A easy lab. Ensure that you have Alger. What was your corrections for the second lab?
So the first one is the apparatus was up to. They are bad handwriting.
Okay. I'm sorry. All right, so the apparatus was obtained as shown in the diagram. That's what you're seeing, right?
Yes, sir.
All right, which other problem do you see?
Just that alone for the.
All right, so if you do that, if you write it in past tense and you go down to your mark scheme, you're going to get 3 marks. That's all. Easy 3 marks. Very easy. All right, I see Nigel has a question. Sir, you was to change 1 to 2. I don't understand, Mr.
You know, you're gonna make changes to our lab one.
Yeah, we made the changes for lab 1. I don't see which changes for lab 2 we're talking about. What's the changes? Could you turn on the mic and expound? All right. L1 to L2. L1 to L2. L1 to L2. Oh, right.
Sir, a
Right.
minus.
Right. You're so right. Is minus?
Yes.
normal length
Yes, sir.
minus L2. You're correct. All right, thank you. That's it. It's the first time I'm actually moderating these labs, so you might see a lot of errors. All right, just bear with me. All right, the next one is for lab 2, and no error in this. Right, so let's go down to our mark scheme. So the procedure, all steps should be in sequence. If you put it in past tense, you're gonna get your full marks. All right, the second one, lab table neat headings. Right, did you see any error for your or you see any corrections, Mr. Alger, for your second one?
Yes, sir.
What corrections do you see?
Just the past. Past.
Could you talk up in the mic?
Past tense.
No, for the table.
Oh, no, no, sir.
No corrections.
No.
All right. So it should have a heading, and it should Mr. I'm not seeing a heading here, Mr. Blake. Right?
Heading, yeah,
Yeah,
sir.
for your second one, and also your calculations. Very important, Mr.
Sir,
Huh?
so not even understand this one, sir.
What do you mean? Right? Oh, right. You weren't there. You weren't there. You weren't there. All right. So essentially, all right. So I see that you have. We're gonna run out of time. We're gonna run out of time, but let me see. You have object A and object B, right? And then let's use object A for example. Let's use object
Object
A.
tower. One of the stone them.
Yeah, one of the stones. Both of them are stones. Let's say we use object A. Now, object A, you would have your mass here, right? Then you would have your volume here, and then density.
We did the table like that there.
No, it doesn't look exactly like this, right? This is an example. Right,
Yeah,
your
but we
table is
did-
neat. The table is okay.
Alright.
All right, so 89.8 and 81. Meter cube, no, it's not meter cube. It's centimeter cube. Centimeter
Alright.
cube. All right, centimeter cube. Meter cube, I don't think you'll be able to hold the meter cube. If it was meter cube, it would be really heavy. All right, centimeter cube. And this is kilogram, of course. Now, our density. To calculate density, how do we calculate density?
That mean you wanna know.
Mr. Alger, how do we calculate density?
Sir, M over V, sir.
M over V, right? Thank you. I turn on the mic, finally, right? So M over V, mass over volume, right? So what would we get here now? Let me see, mass over volume. What's the mass?
89.8.
So 89.8. This is
you-
kilogram or grams?
grams.
Exactly. So this is in grams. So you have to convert this to kilograms, right? Convert this to kilograms, to kilograms, right? So what would we get?
8.08.
Let's try it again. How we calculate, how we change grams to kilograms?
Andre. Andre.
We divide by 1,000, right?
Yes, sir.
So 89.8 divided by 1,000. 1, 2, 3.
Yes.
So that would be 0.089 approximately.
No, sir.
No?
No, 8 down here, sir. So
Hmm?
this should have been 9-0.
Oh, okay. So we round up,
Yes.
no problem. All right, over volume, right? So 0.09 divided by the volume. And what do we have here? Or, you know what? You know what? Leave it. Yeah. Or what? Nice. Yeah, just leave it. All right?
Yes.
Don't convert these grams because they're going to be confusing. So leave that as, so the final thing should be in grams centimeter cube. All right? Grams per centimeter cube.
So basically, don't change the unit them, but still
Don't,
calculate it.
still calculate it, but
Then
just don't
change.
change the units.
All right.
All right, so it should be 89.8 over 81. All right, what do we get here?
Pull up the calculator. I'm done, you know. 89.8 divided by 81.
Hmm?
0.108.
0.108.
It's there.
That's not what I'm getting, right? Let me see. 0.8. Okay. You're getting 0. Anyone else getting 0.108?
Let me check.
Alj, you know, say I used to deal with the maths part.
89.8 divided by 81.